Welcome back to a lecture series on hydrogeology. So, in this lecture, we would like to discuss about the Darcy's law. Henry Darcy in 1856 proposed the movement of water in the subsurface. The other term, the assessment of permeability, the 1856, and the great French scientist by the name Henry Darcy, he proposed, and he has experimented the flow of water through the different rock types in the subsurface, especially on sand first. Rather, we can say very simply, it's the law given by Darcy. It's the relationship between the fluid, water, passes through in a porous medium. If the pores are connected with each other, that is called permeability. And the Darcy law again reflects the permeability assessment. So, this is the common application until still people are using for the assessment of permeability or the movement of water in the subsurface in terms of centimeter per second, how we are assessing by means of Darcy's law. He proposed for a given aquifer, the rate of water flow is directly proportional to the gradient. The rate of water flow is directly proportional to the gradient. What is the gradient at which the rock which allows the water to penetrate down to the surface. So, assume that way back in 1856, he has proposed the groundwater flow is from high hydraulic head to low hydraulic head. From the high head, what does it mean? It means it is one side, if you are sending water from the top after the rainfall, the atmospheric water, after the meteoric water which is coming on the top, the water slowly gets down and then move, not exactly vertically down to the surface. Sometimes it will pass in the head, that is called falling head also. He determined the equation, and that describes the groundwater flow. So, the discharge of water was proportional to the head loss. What is the head, what is the direction, what is the inclination at which sometimes it will passes on horizontal, sometimes vertical, sometimes. And it is also depends on the area of cross section A. It is inversely proportional to the length of the same path. So that's what his experiment. He is a French scientist, 1956. What is his law says, according to Henry Darcy, the discharge was proportional to the head loss delta H, first point, area of cross section, second point. Directly proportional to the area, directly proportional to the head loss, and indirectly proportional to the length of the area. What is the length at which you know that it is indirectly proportional? The experimental verification of Darcy law can be performed in a water through the rate at a rate Q, at a rate normally in a cylinder, at a rate at which how the water which is passed in a cylinder or a cross section area. A is packed with the sand, that is called in the next diagram. I will show you. This is the cylinder, it is being taken. This the material is filled. This is the delta H. And when water which is coming enter here, at which the pressure is here, and when the water is discharged at the other end, Q is the entry point of the water which is sending, and Q is the discharge point. At the discharge point, normally and the water level is different, and the entry point, because of the higher pressure, normally the reading is noted here. The difference between this is called falling head. This is called the head difference, delta H. It is indirectly proportional to the length of the zone which it travels. The distance from the datum plane, this is called the x1, and the distance from the discharge zone, this is called x2. And this is the total distance. The diameter is the A. So, A is packed with the sand having piezometer distance L apart from the figure. Normally, this is being represented by the formula Q is directly proportional to delta H, is directly proportional to delta A, and it is indirectly proportional to L. When you just club together, and then you can very simply say Q is directly proportional to delta H, directly proportional to A and L. Well, delta H and L delta H and L, delta H and the distance represents the rate of loss head or hydraulic gradient. Yes, it is true. Delta H by L is from the entry point of water to the exit point of water. That is called hydraulic head or hydraulic gradient. So this you can make it a small I, delta H by L and A. Or you can also say Darcy's law is nothing but Q is equal to constant K I A, where K is proportionally constant and was found is charging with the type of soil or called permeability or coefficient of permeability. So this is the formula, Q is equal to K I A. Dividing both sides of above equation by A, if you divide by over here A, Q by A is the area, diameter. If you remove the area, what will happen? You will be able to get Q by A and Ki by A, and you will get Q by A, the Ki is the constant V, hence V is equal to Ki. V is the superficial velocity of flow. Superficial because it is not the actual velocity V. So this is being represented as a Darcy's law. The above equation is called Darcy's law in its simplest form, namely the flow velocity. Flow velocity is calculated like this by Henry Darcy's law. Q is equal to Ka HL by L. This is the another diagram representation. Of course, the earlier one which I have shown is very simple. And this experiment also, you see, the head flow is HA. Here, every diagram people have used different experiments, but ultimately the end result of the formula is V is equal to Ki. Right? V is equal to Ki is the constant. What is the assumption of Darcy's law? The soil is saturated. The flow through the soil is laminar. The flow is continuous and steady. The total cross-section area of soil mass is considered. And what he found out from his study, increase cross-sectional area A, the flow rate Q will be high. Increase the filter pack length, the flow rate will decrease. Suppose if you pack on the complete with sands, packing, if the tight packing is there, automatically permeability will be reduced. By using Darcy's law, K can be calculated, where K is the property of the type of soil material, geological material in the soil filter. You can use any of the material. And you can validate the Darcy law. Darcy equation is validated only for laminar flow. So this can be evaluated by using laminar flow. The flow of water through soil depends upon the dimension of particle. It's all same what we have discussed in porosity and permeability. The fine grained soils, the dimension of the voids are very small, and the flow is necessarily laminar. In coarse material, the flow is laminar. However, in very coarse soils such as gravel, flow will be a very high or turbulent. It means in no time the water will come from the inflow to outflow. So this is how it's validated for clay, silt, fine sand, gravel and boulder. It's being calculated the velocity for Darcy's law to be valid, the relationship between velocity and hydraulic gradient. What is the force you are giving and what is the gradient at which the water is penetrating in the different pore spaces of different material. In extreme fine grained soil such as colloidal clay, it's not possible. Normally it will take day together to pass the water. The openings are very small. The velocity is therefore very small. In such soil, Darcy's law could not be able to validate. So with this, the Darcy's law is explained. Thank you very much.